Today we're graphing y equals log base 3 of x plus 1. This is a log function that has been shifted up 1 unit. The first thing that we do is we come up with the parent graph of this function, which would be log base 3 of x. If I rewrite log base 3 of x into an exponential function, then we would have this as our parent. And so then we place -2, -1, 0, 1, 2 in the y column, and then I evaluate those using the parent function, and I come up with the x values, which is 1/9, 1/3, 139. And the reason I do this in this order is because this is a log function, which is the inverse to an exponential function, and so the y and the x values switch. And so because we're shifting this graph up 1 unit, I need to add 1 to every y value. And so I represent that in my table, and I evaluate it. So now I have -1, 0, 1, 2, and 3. And that is the table for this function that has been shifted up 1 unit. And so now I'm going to plot these values on my x and y coordinate plane. So 1/9 is a number very, very close to 0. So I'm going to represent that by putting a point very close to the y-axis without crossing over it at y equals -1. So somewhere there. And then I need 1/3, 0, which is my x-intercept. I need 1, 1. I need 3, 2. And then I need 9, 3. So 9, 3 would go there. And so then I try to create a nice curve that does not cross over the y-axis. And it's easier to do with pencil, but it looks something like this. And again, you want to represent a graph that does not touch the y-axis. And then the last thing left to do is to find the domain and range. So the range of all log functions is all real numbers, and the domain is based on the vertical asymptote, which we said was the y-axis. Domain is x, so x has to be greater than 0. And that is the graph of y equals log base 3 of x plus 1.